Number 5 is taken from the Edexcel International A-Levels Maths Pure 2 paper sample assessment material. An arithmetic series has first term A and common difference D. Prove that the sum of the first n terms of the series is given by this formula. So Sn is equal to this formula, and we need to derive it, or we need to prove that this is it. Let us first take or compare the general forms with respect to this arithmetic sequence that I have composed here. So if I have an arithmetic sequence of terms 1, 3, 5, 7, 9, I call the first term U1 and the second term U2 and the third term U3, U4 and U5. So in order for us to find the sum of the 5 terms, we need to use this formula. So the sum here of n terms is going to be un, it's going to be a, which is the first term, so it's 1 here in this case, plus a plus d, which is term 2, which is u3. So let me just make it simpler. S5, 5 terms, is equal to 1 plus, so S5 is equal to 1, which is the U1 plus U2 plus U3 plus U4 plus U5. So this is the sum of 5 terms. So S5 is equal to U1, which is represented by A, plus U2. U2 is 3, or here it's represented by 1. Let me keep on writing numbers. So U2 is represented by 3. Now 3, I want to write it in terms of the first term. So it's going to be 1 plus the common difference. What's the common difference here? Is 2. So you're going to write it as 2. So it's A plus the common difference. And here it is A. Now in the second or the third term, I want to write it in terms of the first term. It's 1 plus the third term is 5. So what did I do to 1 so that it became 5? So it's first I added to it 2 so that it became 3. Then I added to the 3 another 2, which became 5. Therefore it's twice the common difference 2. So if I want to write it in a general form, it's A plus the common difference times 2. Now let's go to term 4. Term 4, I want to write it in terms of the first term and D. So we start with term 4, it's 1 plus 2, which is 3. Then I added to the 3 another 2, it became 5. Then I added to the 5 another 2, it became 7. And this is the value of the fourth term, which is 7. So I can write it as the first term plus 3 times the common difference, because we added once, twice, 3 times the common difference in order to go to reach 7. So let us write it in a general form, which is plus A plus 3 times the common difference D plus U5. We need to write now or express U5. U5, the value of U5 is 9. So how did we reach 9? Using the common difference and the first term. It's 1 plus the common difference once, plus the common difference twice, plus the common difference 3 times, plus the common difference 4 times. So we can write it in a general form as A plus 4 times D. So in numbers, it's going to be 1 plus 4 times the common difference. So this is on a short scale or on a small scale how we got the formula for 5, or how did we get the sum for 5 terms. Now if you notice here, A the same, and then A plus D is the same, then A plus 2D, which is the third term. Now we come to this term. Now if this was U1 and this is U2 and this is U3, now this here, it's the place of the term, which is the third place, minus 1. And this is U4, therefore this is the place of the term, minus 1. This is U5, so this is the place of the term, minus 1. So if I got A plus n minus 1 times D, it means that I'm finding the UN term. Why? Because this is the place of the term, which is n minus 1. So this is how we decomposed Sn, which is the first sentence here, or the first expression. Now we do the same thing and we write Sn in the reversed order. In the reversed order, we write it from here, A plus, or from the end, and till we reach the beginning. Then we add them up, and while we're adding them up, we have 1 Sn makes 2 Sn. Then here, when we add the first term with the last term, we get 2A plus n minus 1 times D, etc. And in the end, when you're adding these terms together, one after the other, you're going to have the same 2A, or expression 2A plus n minus 1 times D. And how many of these are there? All in all, they are n, because we have n terms. So it's S2S equals, or 2Sn equals n times this expression n times. Now we need Sn alone, so Sn is divided by Sn is equal to n over 2, because we take the 2 to the other side, it means we divide by it. And this is how we got the expression, or the formula, for the sum of n terms in an arithmetic sequence. Now we come to part B. A company which is making 200 mobile phones each week plans to increase its production. So starting with 200 mobiles, the number of mobile phones produced is to be increased by 20 each week, from 200 in week 1 to 220 in week 2 to 240 in week 3, and so on, until it is producing 600 in week n. Find the value of n. So since we know that we have an arithmetic sequence here, we need to find in which week we're going to reach 600 mobile phones. Therefore, we need to find UN, which is the week where you're going to reach the 600. So you already have the value for UN. It's equal to the first term plus n minus 1 times D. And this is the formula for finding the nth term of an arithmetic in an arithmetic sequence, where it is given in your booklet, in your formula booklet. So now you replace 600 for UN, you replace 200 for the first term, and then n is the one that we're going to find, and 20 is the common difference. Now expanding, you're going to get 200n equals to minus 200 plus 20 plus 600, therefore n is equal to 21. So in the 21st week, you're going to, or the company is going to produce 600 phones. Now in part C, the company then plans to continue to make 600 phones each week. So now it's stable, and each week they are producing 600 mobiles. Find the total number of mobile phones that will be made in the first 52 weeks, starting from and including week 1. So the increment is between week 1 and week 21, and then after week 21 they have a stable production of 600 mobiles. Therefore, we need first to find the sum of the total number of phones made in these weeks. Then we multiply the difference, or the number of weeks, by 600 until we get week 52. So in here we found the sum of the 21 weeks, that it's 8,400 mobile phones. Then from week 22 till week 52 the production was constant, which is 600. Therefore we multiply 31 weeks times 600, we get this amount. We add them up together, so we get the total number of mobiles produced from week 1 till week 52. How did we get week 31? Because we subtract the weeks that are between 22 and 52, and we multiply them by by the number of production, because it's constant. Therefore we got 18,600. Adding it up with the previous number, this is why we got 27,000 mobile phones produced from week 1 till week 25, till week 52.